Hello guys, good evening. First of all, welcome to this webinar. Myself Balraj, I'm a cybersecurity analyst working at the BCBUZZ Technologies, and this webinar is based on OWASP top 10 vulnerabilities. Let's dive in. First, what is OWASP? OWASP is an open web application security project. It is a non-profit organization focused on improving software security, and they offer more free resources like OWASP top 10 vulnerabilities, not only for web application and also for mobile API, etc. And then was testing guide. It was for like penetration testing standard and was ZAP. It's a intercept request response interception based tool used for the penetration testing and WebGoat. It's a vulnerable site for practicing web application security. These are the top overs in the 2021 regulation. First one is broken authentication. Second, cryptographic failures. Third, injection. Fourth, insecure design. Fifth, software misconfiguration, vulnerable and outdated components. Seventh, identification and authentication failures. Eighth, software and data integrity failures. Ninth, security logging and monitoring failures. And the last, 10th, server-side request forgery. The first vulnerability of the worst often broken access control. Just imagine this, like you are a user, you accessing your data. Other than your data, you are accessing someone else's data is belongs to this broken access control. Users can access resources that should not be authorized to access. See that URL that was assigned to a normal user whose ID is 124, but he is changing his ID to 124 from 124 to 123 by accessing the other users. It became the broken access control. In this webinar, it was not only full of theoretical, it was full of completing labs, more focused on practical knowledge and the real impact of the broken access control or data theft, privilege escalation, and account takeover. Let's see some practical session. I'm in the portsinger.com, which was useful for learning web application security, not only theoretical and also practical. Go to labs. First, we are going to access control. Access control vulnerabilities. Let's start with the first lab. This lab was full of unprotected admin functionality, and it has a unprotected admin panel. Our goal is to find the hidden panel and delete the user Carlos. Let's access the lab. Here's our target. First, our goal is to find the hidden admin panel. First, normally try to gather what are the functionalities of the website and what the website can do. Try more in information gathering, login page, and in the source code, nothing interesting. Let's try robo.txt. See, we have a administrator panel. Let's say we have access to that. Yeah, we are in the administration panel, and our goal is to delete the user Carlos. Thus, the lab has completed. In this lab, we had unauthorized access to this admin panel, and we deleted this another user named Carlos. It is the it refers to that unbroken authentication vulnerability. Let's move to the next lab. unprotected admin functionality with unpredictable URL. Has admin panel it was located in unpredictable location. The location is disclosed somewhere in the application, and we have the same goal. We have to delete the user Carlos. Let access the lab. I think just like the previous lab, we have to delete the admin Carlos, but the admin panel is somewhere in the hidden. Here's our target. A normal e-commerce site seems to be a normal site, nothing interesting. Let's try the same robot.txt. Not found. Then let's see in the source code. Here you see, let me zoom in. The admin panel in this location. I just copied that and thus we are in the admin panel and our goal is to delete the account of the Carlos. Yeah, we have successfully finished this task. Next, let's move to the next lab. And the third lab is user role controlled by request parameter. They had said that the admin panel is in this location and the same goal, and they provided some credential for us to log in. Let's access the lab. Same as the usual target with as a e-commerce site. First, let's log in. I had used their provided username and password. I am logged as a Vainer, and our task is to reach the admin panel for now. Only administrator can access this lab, like admin panel. Let's use WebShoe to do some interruption in the request and response and tr- try something to have a way to that login panel. I'm going to use the Chromium for the interruption. Let's capture this request. It's as usual, get request, first name, cookie, user agent, everything looks usual. So first we need to log in this Chromium and the username Vainer and password this. Mm. We had login. Now access the admin panel. Here's our request. Everything as usual. Did you notice that here's an condition is it will check we are admin or not, and it was false. I am going to change that into true and forward the request. Yeah, I had successfully accessed that admin, and our goal is to delete the account of the Carlos. So I am going to change this here also. Yeah, we have successfully deleted the Carlos account. With that, the lab has finished. Let's move to the next lab. And the fourth one, user role can be modified in user profile. They had said the admin panel in this location. It was only accessible by the role ID to it's a user who have role ID up to our task is to access the admin panel and delete the user Carlos and they provided the credential. Let's access the lab just like the before lab, but yeah, extra condition. Role ID is just like usual. First, I'm going to open this in the Chromium and let's log in. And the password and the password Peter. Yeah, we have successfully logged as a Weiner. Let's access the admin panel. Through they had mentioned that that was in the location of admin. We didn't have access to that, so I'm going to use that book. First, let's see right request history. Here it is. Everything looks like clear as nothing abnormal. Let's try to enumerate. We have any other way to access the admin panel. Everything is usual. We have a option to update our email. Let's try Weiner one. Yes, successfully update that. Let's see the request of this update email. In the request, upgradable email address that we had given. And in the response, you will notice that role ID of us is 1. And we have to first change that. Let's turn on the intercept and update the email again with 2. Here's our request. And one, as they mentioned, the user who have the role ID too will have the access to this admin panel. So first we have to have that update that user ID. Let's add another parameter called role ID, and the value is 2. As I mentioned, let's forward. The email ID had updated, and we have the admin panel. Let me turn off the interceptor. And our goal is to delete the account of the Carlos, and thus we have successfully completed this lab. So, and the last lab of the broken access control. And in this lab, we have horizontal privilege escalation vulnerability in the user account. To solve this lab, our goal is to have the API key of the Carlos, and they provided the credential, like we have logged in as a Vayner. Let's access the lab. Here's our target, like usual. First, we log in, use the credential like Vayner, and the password is Peter. And we have a API key of the Vayner, but our task is to obtain the API key of the Carlos. Let's try to discover any information. Nothing interesting. API key. Did you notice that in the URL it have a ID called Vayner? If we change the ID to Carlos, yeah, we have logged in as a Carlos, and we have the API key of the Carlos. Let's copy and commit it. Thus, we have successfully completed this. I hope you can understand this uh, broken authentication from this file of the lab. Let's move to the next vulnerability. It was the second vulnerability was cryptographic failures. It's also a famous vulnerability which refers to sensitive data is not properly protected, both in storage and during transmission. Example: password stored in plaintext HTTP instead of HTTPS. Weak encryption algorithm. Some practical examples like storing password in the plain text of my password 123 instead of using proper authentication or hashing algorithm like SHA or Bicrypt. Let's go to the lab of this. For this lab, yeah, we are going to information disclosure and this lab. Information disclosure in error messages. The lab verbose error message reveals the lab reveals the versions of the third-party framework which was in the verbose model. It can be useful for the attacker to for the exploit. Our goal is to identify the version number and have to submit that. Let's access the lab. Again, the usual target. Nothing interesting. Let's use the workshoot. Let's open Chromium. We didn't have a login page. It's just a static page. Let's intersect. Here's our get records. Everything usual. Let's view any product. This product has a product ID, which is two, and the rest of them are the usual. Let's make the product ID into improper. Let's type any other improper ID like slash or hyphen or colon, any other. Forward. Thus, we have a verbose error message which clearly explain why this error has occurred. And our task is to find the version. Here in the bottom, we have the version of the Apache. This website is running in the Apache server. I just going to copy this and submit the answer. Thus, we have successfully finished this lab, and it was a major vulnerability. The version will make the attacker easy to exploit. And back to the PPT. And the third vulnerability is injection. In the OWASP Top 10 2021 regulation, user input is interrupted as a command or query. The injection mainly focused in the input field of the database, like commands, login pages, maybe filters, and the most common injection is SQL injection. Example input, you can see that payload, which used in the login page or bypass that authentication. And types of injections are SQL injection, command injection, LDAP injection, expert injection. Let's move to the lab. SQL injection. Let's access the first lab. This lab contains a SQL injection vulnerability. The product category filter. When a user selects a category, the product carries out a SQL query like the following. Select all from products where category is equal to gift and resilient. And our goal is to perform the SQL injection. Let's access the lab. Here's our target. Just like the given, here's a filter which useful to filter the results based on the request. Let's connect to the bug. And the target state is loading. Let's intercept the request. Here's the request of the filter called accessories. Let's do our SQL injection in the category parameter. And this is the SQL injection payload I'm going to use in this lab. And I just forward and turn off the interceptor. And here our SQL injection has successfully, the query has successfully injected. Just a minute. Due to network issue, it's not successfully done. Yeah, we have successfully completed this lab by injecting the payload. Let's move to the next lab. And in this lab also contain a SQL injection vulnerability. The login function to solve this lab perform SQL injection attack in this name of the user called administrator. It access the lab, here's our target, like the usual target. We have to do the SQL injection in this login page. First, let's try admin, invalid username and password. Then let's try to log in. Our goal is to log in as an administrator. So then, and this is the payload I'm going to use. It works like the first is considered as the username, and rest of this are eliminated. I'm going to type the some password. It's not a proper password. Yeah, we had logged in as an administrator, and the lab has successfully completed. Just like I used to do the payload. I think it's enough for the SQL injection. Let's move to the PPT. And the next is insecure design. It's the fourth vulnerability in the OWASP Top 10 2021 regulation. Security problems due to poor architect or design belongs to this insecure design. Example, no rate limiting on login, no fraud detection, weak password policy, and example attack, brute force logging. Just imagine we have a website without a rate limiting. The attacker can try 100 or 1,000 times, and in the times he will find the proper credential for the login, and it can be prevented by forcing threat modeling secure design patterns. Let's move to the next one. And the fifth vulnerability in the worst top 10 is security misconfiguration. Improper configured servers or framework belongs to this vulnerability. Example, default credentials, directory listing enabled, debug mode enabled. See that practical example which has a website with .git application which results in the source code exposed. The attacker easily access the source code and understand the website easily, and it will easy to him to attack. And the prevention is disable unnecessary services which are not in use. Remove default credential, harden server configurations. Let's see some of the labs. And for that, I have chosen the path traversal. Let's move into the first one. This lab contains this path traversal vulnerability in the product images, and our goal is to retrieve the passwords of the file. Let's access. We have the usual target, a e-commerce site. Looks like everything normal, and we didn't have a login. And it's just a static page. Let's connect to this to Burp. I'm going to make a highlighter, and let's intercept. And this is our get request. Look like the usual get request. Let's forward and see the servers send these requests, which all have file name with a image. Let's forward one of these requests to the repeater. Let's send just image. Let's change the image name into a payload and is the syntax of the payload. And our goal is to retrieve the password. Let's try. Yeah, we have retrieved the passwords of the system. Sorry, let's turn off the interceptor. Forward all. And this is the passwords of the file, like they had asked the, and the lab has completed. Let's move to the next lab. Just like the before lab we have faced it, it also have a path traversal vulnerability, and we have to find the password file just like before. Let's access the lab like our usual target. We didn't have a login page. Just look the login page, source code of this page. Nothing interesting. Just to do like before, we move to the workshop. Let's turn on interceptor and gather the request. Just like before, the server sends the responses. I'm just like before. I'm going to send one of them in the to the repeater and just see. It's an ordinary image. Let's try the same payload. Let's send. In the response, it no such file. Let's modify this payload into a direct request. Thus, we have retrieved all the data, just like they asked. First, turn off the forward. Yeah, we have successfully completed this lab by retrieving the password. Let's back to the topic. And the sixth vulnerability is vulnerable and outdated components like vulnerable or malicious libraries we are using in our application which became a target for this attacker. Example log4j vulnerability, and the impact was remote code execution, full servers compromise, and the prevention for this is regular dependency update. Let's move to the next. Identification and authentication failure. Weak authentication mechanism or poor authentication mechanism are refers to this. Example, weak passwords, allowing weak passwords, no multi-factor authentication, session ID exposed in URLs, just like the bottom. And prevention for this is implementing multi-factor authentication, secure session management, strong password policies by enforcing. Let's do some of the labs for this. And access the authentication. to the first lab. Here we have lab is vulnerable for the username enumeration and password brute force attack, predictable username and password, and they have provided the username and password word list. Let's access the lab. We have a target which is a blog, and our target login page. Let's try a default admin, and in the result it will had a lot like invalid username. It's a nice hint. Let's move to the workshop. Just a minute. First, we have to capture the request of the login. Let's turn on interpreter, and in the intercept we have our post request, which we have our username and password that we have provided. Let's forward it to the interceptor, sorry, intruder. Here we can set the payload first for the username and the word list they have given, and this is the word list for the username. First save this in a file. I'm going to create a file in this location and name of username and save. Let's load that file. Successfully loaded and the payload was successfully set. Let's start the attack. Now I had currently using the Shoot community version. Other than that, we have the Shoot also provide the professional version, which was more advanced than this. We have 101 target. In the meanwhile, I'm going to create a file for the word list password, and this is the password they had given. Let's copy, and I'm going to save in a separate file which called password. Yeah, let's check the status. It has already tested 57 and few more to complete. Here you can check the request and the different response received, status code, the payload we had using, and the request number and length of the payload. Sorry, request. And did you notice that a single request has a different length? The other response request are having the same value length, but this one have a different one. The name of affiliate in did you hear the incorrect password? Let's render. Okay, fine. It shows that the username has correct, but the password was incorrect. Let's note this username affiliate and then stop this process and let's start. Just change this username and add the payload in this password. And for the word list, first clear this and load the password list. The attack has started and we have 100 payloads. Just wait for the result. If there are any changes in this length, still no more difference in the length, and it has completed 40 of them. Still no more changes. Just a minute. Back to the intruder. Still no, we have no changes, and it had completed 60 of them. And just like before, it fixed the username to this and making the brute force in the parameter of the password. Still it in process, and you still in the process. It has completed 80 of them. Let's see what was that password. And 90 had completed, and this intruder in this community version was just a demo model. The original version is in the pro version. We have a difference in the length, and then the name of the password is matrix, and the redirection has occurred. Let's turn off this and try to make the login. First username and the password. Yeah, we have successfully logged in as in this unique username, which we had brute force. So we have successfully completed this lab. So let's back to the topic. And next, we have software and data integrity failures. Code or data is not verified or integrity or belongs to this vulnerability. Example, installing plugins from untrusted sources, unsigned software updates, and some of the attacks like injecting malicious packets. And for the prevention, use signed updates, verify software integrity, use CI/CD pipelines for the development and deployment. Let's do a lab in this. For that, we are going to this JWT, and the first lab. This lab uses a JWT based mechanism for authentication. Due to implement flaws, not verify the signature of the JWT, and our goal is to get the access of the login admin panel and delete the user Carlos. And we have a credential they provide us. Let's access the lab. JWT based mechanism. It's a JWT is a JavaScript web token for it's a token based authentication. And the target we have it's a blog website. First login, username and the password. And we have successfully logged in as a user. And our goal is post admin panel. So we didn't have the access for that admin panel. Let's get into the work first. Turn off the intercept. First logged in. Successfully logged in. Let's let's try let's try to access the admin. Say, let's see the request in the book. Let's find where that authentication checks will happen. Like the session. So looks like the authentication is happened in this session cookie. Let, let's try to read the session cookie. Yeah, you will see that it is decoded. It has a parameters in the JSON format and the sub has the username or we have to log in as admin. I'm going to change that into administrator and apply changes. It will change that request and forward. Or we have successfully had the access to this admin and our goal is to delete this. Let's change here also into administrator and forward the request. And thus we have successfully completed this Slack by deleting the user called Carlo and back to the PPT. Next, we have security login and monitoring failures. Attacks happen, but no one has noticed that. Example, failed login attempts, not logged in, no alert system. Impact, breach detected months later, and the prevention was implement centralized login system like SIEM and monitor suspicious activities. And the last 10th vulnerability is the SSRF, server-side request forgery. The attacker tried to trick the server by executing a request or command by fetching the data in the internal server. And the real impact was access internal services. The attacker has access to into cloud metadata, data expose, and the prevention was validate URL, block internal IP ranges, use allow list. These are the key takeaways. Just like we had saw the before, the OWASP top 10, the why the web application is became a primary target for the attackers. It's because in this modern modern scenario, most of the services, records, functions happens in the web application, and it's became a wide surface attack area for the attackers. And source code is essential for developers. Security must be implemented into the secure development lifecycle. Regular testing and monitoring are crucial. Yeah, definitely. Preventing vulnerabilities better than fixing. Of course, security is shared responsibility across terms. And thus, if you have any requests or questions, you may drop that in the comment section. And this is our website. Here you can have more webinars and classes. You can, if they are free, all free. You can enroll and gain knowledge. And this is our WhatsApp community. And finally, thank you. Thanks for joining this session.